Good morning, everyone, or good afternoon, depending on where you are in the world. Uh, my topic today, as you can tell, is broadband architectures for the future. Um, we are in a very exciting period of time right now as far as broadband technology. Uh, Obviously, there are a number of other factors associated with that. Let's shoot through the agenda real quick. Uh, Probably at the top of everyone's mind these days is the historic funding situation that we've got here in the United States, with really a number of different programs, tens of billions of dollars available. It's a very exciting time. It's a time that I think virtually everyone is involved in, from uh, traditional telecoms to utilities, looking at either stringing the fiber or perhaps becoming a broadband provider, and scores of others in other models and so forth. But there are some caveats, as there always are when the government decides to provide funding. So we're going to talk a little bit about that just to kind of set the stage, and to really kind of drive home the point that regardless of the availability of funds, there is still a need to spend wisely, right? So to that end, we're going to be talking about durability of solutions, not just durability of hardware and perhaps software, but durability of the platform in general, and providing a solution for you that will not only meet today's requirements, but will scale fairly easily as the network grows, not just in terms of bandwidth, but in terms of what we're asking that network to do. Uh, to that end, we're going to speak more directly to our intelligent middle mile. I'll define middle mile for you roughly if you're not familiar with that term. Generally, the network, the edge of the network where customers are connected, regardless of what those customers are, whether it's residential, business, or a cell tower, what have you. That is what we generally consider the access part of the network, right? Makes sense. That's where customers access the network. Uh, those devices have a couple of things that are characteristic of an access device. One is that you buy a lot of them, right? Because there are various areas where you've got residential, you've got business, you may have to go out to a cell tower, what have you, right? So you've got to buy a lot of those. The other aspect to that is they have to be fairly low cost, again, because you have to buy a lot of them. So those devices are not necessarily the best place to put the intelligence in your network. What they do very well, and that is bring a customer onto the network, apply some basic classification to that type of customer, but then hand it off to the middle mile. Middle mile, as the name indicates, sits between the access and then the core of your network, which is generally for a rural telco, for a utelco, for even for larger providers, is where your core routers go out to the internet, right? So between customers and internet, you have this thing called the middle mile, right? And we've had it for a long time in terms of long reach fiber capabilities, DWDM, and so forth. But what we're talking about now is an intelligent middle mile, and we'll go into that into more detail. Bullet number 4: how do I manage this? Right, as the demands on our networks become more complex, and as we ask more and more and more from our networks, uh, the need for a management tool that scales along with the requirements becomes more and more important. So we're going to talk about Ribbon's version of management and why it really is unique in the industry today, and something that I think you need to take a serious look at. Okay, so back to money, right? Everybody's favorite topic. We have so many different programs out there today. RDOF BEAD, Reconnect 5 is now available. Middle Mile Grant. We've always had RUS, right? RUS for quite some time. that continues, right? One thing that all of these have in common is that they're almost all CapEx, which means obviously you're buying your equipment, you're putting the fiber in the ground, you're getting a start on building out your network or doing a network refresh. What is unfortunately absent from most of these programs is OpEx. There's no operational funds to keep you whole as time goes on. So we're going to talk about how to address that with a number of different strategies and things to think about, some of which you may be familiar with, others may be new to you, I hope. The last bullet here under public funding is this really is historic, right? It is, I've been in this business for about 25 years. Many of you I know are no doubt in it much longer than that. I've never seen levels of funding like this, and I'm unlikely to ever see them again. And so there is a need to spend what we have very wisely. So to that end, let's talk about cost effective, right? What does that mean? First of all, let me just throw one term out entirely, and that is future proof. There's no such thing as future proof, at least in perpetuity, right? Future proof means that things never go obsolete. Well, of course they do, right? Everyone knows this. But what future proof, what cost effective means as opposed to future proof is that we can extend. First of all, keep your initial investment low, meeting your requirements without overbuilding, providing scalability so that when you grow, you can easily move into that without doing any forklifts, getting you the largest return on your investment and the most rapid return on your investment, right? So if we can shorten the time to revenue between deployment, getting orders in, and then turning them up to start paying for this investment, then that's part of cost effective. Total cost of ownership, of course, this is, TCO is always a question when we go out and talk with customers. And then finally, the refresh date. So no matter who builds your network, at some point you're going to be replacing that network. So let's just use some general time frames, right? So if I build you a network and it lasts for 5 years, then that means you're doing all of this again in 5 years, right? That's pretty extreme. Hopefully we won't have a situation like that with any vendor out there. But if I can move that to 10 years before you're starting to think about refreshing, then I've doubled your return on investment, if not more, as your environment continues to become more sophisticated and you provide higher revenue services, right? Which I think is highly likely as the internet grows and as the applications that we see continue to become more sophisticated. So what we're talking about as a part of cost effectiveness is extending the life of that network. It's easy for me to say that when you put a ribbon network in, that we fully expect it to be there for a minimum of 10 years. We have customers that have networks that are 15 and 20 years old, and we're still running them for them, right? So at a certain point, of course, in the future, technology gets so much better and parts availability and so forth, and there are inevitable endpoints for particular technologies, right? But what we are trying to do here at Ribbon is move that out as far as possible, so we don't have to go through this again. This is our design philosophy, if you will, and it's just some basic knowledge that I'm sure most of you are already familiar with, but I've put a graphic around it just so we can use it for discussion purposes. So I'll first direct your attention to my triangle on the left-hand side. So what we're looking at there is the cost arrow. So the wider that triangle gets, the more cost is involved for that technology. So down at the bottom, the narrowest triangle is layer one optical, also known as DWDM. There are obviously more than DWDM involved in that, but that is in general what the industry is talking about when you talk about building optical networks, right? Uh, bit for bit, that is the least expensive way to move data across your network. However, there's not a whole lot of additional handling, white glove treatment, traffic engineering, protection schemes, things like that, right? It's pretty basic. It moves data and it moves it very efficiently. This is a service, for instance, that you would want to use to sell to a backhaul customer who just wants you to carry 100 gig from one side of your operation to another. They don't want you to touch it. They just want you to, they want a pipe all the way through. The best way to do that is going to be with layer 1 technology because it's the lowest cost for you. Moving up in that triangle, we get to layer 2 switching, which we certainly have had for years and years now. Was the default method of building broadband networks for a long time. This is where you get rudimentary traffic engineering, some protection schemes, and other traffic handling benefits, right? And one reason why that we built switching networks was they were affordable, right? They're right there in the middle of that cost curve. I get some of the tools I need to provide that traffic handling. But 10 years ago, building a routed broadband network was just prohibitively expensive, right? Very, very expensive. And so at the top of the triangle, of course, you see routing. Routers can do it all, right? Routers can provide ultimate control over the traffic, and with some amplification, routers can provide long haul as well. What was needed to move from switching to routing in the broadband space was a few protocols, right, which have come along, and we'll talk about those, that allow you to build really a custom broadband network. And then we needed the cost to come down, right? So the cost of router ports was, in some cases, 10 times what a switched port was for the same bandwidth. And it's tough to make ends meet when it's that expensive. So those prices have come down. Overall, using my triangle diagram here, that triangle is narrowing at the top, right? And so what we're going to talk about is moving towards more of a routed optical network or an IP over DWDM solution, which we're finding in the industry is gaining wide acceptance and a lot of interest from our customers. Okay, so these are the layers of the network. Of course, at the top, you've got management, and we'll address that as we get there in the presentation. So here's a good example of really a number of things. This is a utility customer of ours down in Georgia. Their primary build on their network covers the state of Georgia and attaches to 38 EMCs, local co-ops, but it actually extends over 4 states. And this is an all layer 1 optical network, DWDM. The network was put in over 10 years ago. And at the time, 10 gigabit wavelengths was the de facto standard. Everyone built 10 gig wavelengths. When you needed another 10 gig, you just added another wavelength. And so it went 10, 20, 30, 40, 50, etc. Well, without forklifting anything, with simply adding the new cards, this network is now carrying 200 gig wavelengths. So now the wavelengths are 200, 400, 600, 800. Obviously, a lot more scalability there. They can still run their 10 gig networks, their 10 gig wavelengths as well, if they wish. So a long runway for this particular network. Pushed out that refresh date well into the future from when they first put it in the ground. This network is actually capable of running 400, 800, or 1.2 terabit networks, all on the existing infrastructure, right? So scalability from 10 gig to 1.2 terabit without any forklifts, right? Okay, so enough on that one. Let's move forward with routed broadband. So the terms for this network, for this type of network, are routed optical networks, IP over DWDM, direct connect routers is another example of a name that's used. Essentially, what we're talking about here is we remove the optical layer entirely. We can. We don't have to, but we can. And we'll talk about management in a bit. And we're just talking about this layer 2 or layer 3, specifically layer 3 network construct, right? So what can I do with just a layer 3 solution, right? Why is that a benefit to me? What are the advantages and so forth? So let's talk about applications for a minute. As our internet life as a culture moves forward, we're finding more and more uses for the internet, right? So again, 10 years ago, dedicated internet access, DIA to everybody was what we used, and we went out and hit websites, right, and Facebook and things like that, right? But the Internet of Things, jokes about an intelligent refrigerator aside, the Internet of Things is really coming into the fore today. Nowhere more importantly than in telehealth and telemedicine, where there are implanted devices that can communicate with a central monitoring station remotely over as much distance as is required to reach the patient. And those devices can provide blood sugar information, enzymes, heart, cardiac, cardio information, and so forth, right? And then adjustments can be made to that patient's treatment remotely. Well, it requires, obviously, a reliable solution with low latency, right? This is going to become more and more important as the baby boomers continue to age, and we have more of that medical industry that needs to reach out and address issues in the patient's home or perhaps in a care facility. Remote learning. We certainly saw this during the pandemic. School kids not able to go to school. The quality of their education dropped significantly, particularly for the kids that didn't have home broadband, right? This is one of the reasons why the broadband initiative that the government is putting out there is so important. The quality of that learning content, not just for primary and secondary school, but also for college, university, technical schools, and so forth, is really dramatically improving, and will only continue to do so, right? So whether there is a physical need to stay away from school, or whether it's a distance situation in some rural areas, of course, there's a long way from where the child is or where the student is to where their institute of learning is, right? And then, of course, there are security and reliability concerns there to make sure that the service is being delivered adequately and there are no unauthorized access. And then finally, immersive experiences, right? This is still kind of on the edge. Some of you may have the VR headsets, sort of early caveman type VR experiences, right, with lots of polygons and pixelization and so forth. But those devices are getting better and better and better. I got on an airplane the other day, and someone was walking down the aisle, boarding the airplane with an Apple Vision Pro on, and they were navigating the aisle, but also you could see their head moving, and they were interacting with a virtual world while they were walking. And I think this is just a matter of time before we see this in a lot of places. It is like all technology, it's a double-edged sword. But I think for the benefits that it's going to bring about, I think it's probably not only inevitable, but probably a good thing. But all of these technologies here require extra handling, right? What I might call white glove treatment for that traffic, particularly telehealth, telemedicine. Uh, those types of traffic need to be absolutely reliable and guaranteed a path through the network, right? Remote learning, almost as important. And then when you count e-commerce along with virtual meetings and other applications, as well as the multi-billion-dollar gaming industry, you start to see that the immersive experiences, the headsets, and so forth, are also of really high importance. So, how do we handle these? Right. The fact is that you can't handle them appropriately with just a layer one optical network. It is a challenge to handle them with a layer two network. In fact, layer three is the appropriate tool for these. And here are a few market trends that we're seeing within that layer three space. We're going to talk about traffic handling here in a moment, but I want to set the stage by looking at the other benefits that have come about here in the past couple of years with regard to IP routing. So, of course, traffic growth. Traffic is always and ever presently growing. Capacity. Capacity continues to grow to handle that traffic growth. We are now building as a standard 400 gig wavelengths on a network when just a few years ago we were building 100 gig, and before that it was 10 gig, right? We can see 800 gig and then terabit wavelengths in the not too distant future. So that is only going to continue. Now, keep in mind that this is just raw capacity. This is just raw bandwidth, right? We are going to have to handle that bandwidth appropriately to make sure that our traffic is delivered properly. There are some problems where you can't simply throw more bandwidth at it and have that solve it, right? Topology. So, sort of dating back to the Sonnet days, everything was in a ring, right? Occasionally you would have a linear network, but virtually everything was built in a ring for good reason, for protection and so forth. But with routed technology, now you can build more complex topologies, right? You can use, certainly you can do a ring, but you can build partial mesh and full mesh networks where you have, N plus one options in terms of protection routes, right? Which gives you a lot more reliability. You can cut down latency times by shortening the path and so forth. So topologies are getting more complex. Routing makes that possible. Network simplification. That may seem like a contradiction to everything I've been saying so far, but the networks are getting simpler in that the protocols are getting more powerful, and particularly the layer three protocols uh, with regard to broadband applications are allowing us to do a lot more with fewer protocols. So that is a huge benefit and one that may not be immediately apparent, but certainly is true. You're also going to see a lot more automation, and we'll talk about that when we talk about management, but automation, which allows you to cut down on the grunt work that your network operators and administrators are having to do. Open and unlocked. So once upon a time, still the case with some locations in this industry. Vendors wanted to lock you into one particular vendor. You have to buy everything from us, all the optics, everything else has to come from us, or we won't support it, or we just won't sell it to you, or what have you, right? That is quickly moving into the past. Now networks are built on open standards. They are unlocked in many cases. Certainly the case here at Ribbon, we don't key our optics. We build to entirely open standards. In a nutshell, our philosophy is we're never going to be the vendor from one end of the network to the other. And that's good for you. That's good for you because then you get to buy best of breed instead of just best of brand. And so since we're going to be working with other vendors in your network, we need to work and play well with others, right? And this is a philosophy that really should be widely adopted across the industry, right? So open and unlocked. We'll talk more about that in management. Network convergence. So this is sort of a general term that talks about networks providing more than just a single function. It allows your network to extend to providing multiple layers of service from a single device or perhaps a couple of devices, rather than going in and having to build separate networks for each individual application. And that's where we're going to start talking about revenue. This is a quick slide to talk about the term IP over DWDM or routed optical networks, right? This is a very pragmatic diagram that basically shows, if you look here at the top, you see, so NPT is short for our routers. We call them Neptune routers. So this is 3 Neptune routers that are connected point to point to point with DWDM in between. You can plug the DWDM optics directly into the router, and then they can talk to each other. This can entirely eliminate the DWDM layer. So an optical network, in some cases, you don't even need that. In other cases, it will operate over the network, over a DWDM network, but you don't need to buy transponders and muxponders anymore, as well as individual optics just to convert from a gray wave optic to a narrowband optic, right? So this is an advance in the industry. It's fairly simple and fairly subtle, but it is highly impactful to your bottom line when you can plug your DWDM optics directly into the routers and then have them talk to each other. This is a good example of that. This is a customer of ours in Kansas. They elected to completely eliminate the optical layer. So there is no DWDM here in terms of transponders, muxponders, ROADMs, muxes, and so forth. None of that is in this network. These are directly connected layer 3 routers operating segment routing, IP MPLS, and they're operating at 400 gig, right? This is another advance recently that the 400 gig optics exist, but also that they are much lower cost than you might expect. So what that allowed us to do is build this network at 400 gig on a backbone, which will extend their refresh date far into the future, provide that high touch, white glove treatment to the traffic, as well as sub 50 millisecond failover, etc., and then save them a tremendous amount in terms of initial cost, administrative cost, OPEX, and then, of course, total cost of ownership, right? So there are many, many reasons to take a look at routed optical networks or IP over DWDM. So now we're going to start talking about, we're going to go back to those specialized types of traffic that need that white glove treatment, right? They need special handling. Your network needs to be able to detect a customer coming in, automatically build a service for them that is specified by that customer, whether it's SLA requirements, whether it's an HOV lane through the network, scalable bandwidth that can burst and then collapse again. It needs to be able to do all of this dynamically without human interaction. And it needs to meet that customer's requirement because obviously there is a monthly charge that person is paying for all of those services, right? So the intelligent middle mile detects those customers, builds what they need and either leaves it up if necessary or tears it down until the next time that customer comes along, and then it will stand it back up again instantaneously, right? So an intelligent middle mile is additional staff for you, essentially. It is provisioning, it is monitoring, it is automation, and it can also be uh, 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 troubleshooting, right? And all of this can be done uh, in an automated fashion. You set it up, you decide what behavior you want the system to provide, and then it will continue and provide that behavior for you in terms of customer service. So what we're looking at here at this in this particular diagram drives home the point that obviously we need enough bandwidth to carry the traffic. This is something we've known for years, so nothing new there, right? Um, but that's generally where it has ended in the past, is that we just throw bandwidth at it and that solves the problem. My message today is that that's no longer going to solve the problem when we have these advanced services, which by the way are generating additional revenue, right? So the service needs, the service awareness in my second little unhappy face here, right? The service awareness in that particular network uh, is not there. We may have enough broadband backbone, right, in terms of raw bandwidth. But if the network can't service those demands, then of course, unhappy customers and a revenue hit. So when I talk about scaling in 3D, this is what I'm talking about, right? I'm talking about, yes, enough bandwidth, but beyond that, building an intelligent middle mile that provides the service needs that your customers are looking for. So this is a slide to just kind of walk you through that traffic engineering, right? Internet-based entertainment. So we're talking about Netflix here. You've got to oversubscribe because not everybody's on Netflix at the same time, and you have limited resources in some cases. So oversubscription, obviously, just a part of doing business, right? And there are algorithms for calculating that. So internet-based entertainment. Oversubscription is an important piece. It's best effort traffic, the set-top boxes, over the top, that type of technology, very latency tolerant. So we don't need to spend a lot of time traffic engineering the latency for this particular one. Now, business connectivity, reliability is essential, of course, right? And so you need to put protection in place. Distance learning, we talked about it earlier. Security, walled gardens, making sure that unauthorized access is prevented, and then of course telehealth. Right, there are restrictions, government regulations, HIPAA regulations to protect health information. That's going to include electrical impulses from a pacemaker and so forth. And so encryption may be important there. Certainly low latency, reliability are going to be pieces of that. And so what we're asking our network to do is balance all of these things, right? These are just a few examples. Autonomous vehicles, certainly another one. VR and virtual experiences is yet another. These are only going to grow in the future, right, in terms of their bandwidth usage, but in their requirement for special handling and service awareness. So here's one way that you can handle that. This is a diagram describing network slicing, maybe a new term for some of you, although you're probably familiar with some of the ways that we have sliced in the past. So VPN is a way, right? It's a software method of slicing. So when we talk about slicing, we're just talking about isolating traffic, right? So one hardware method of slicing traffic would be to put every customer on their own pair of fiber. Obviously impractical, right? So we put everybody on one pair of fiber, but then we perhaps split that into DWDM wavelengths. And so now I've got a software and a hardware method of isolating traffic between wavelengths. Within that, we have VPNs. Obviously, there are many other ways to do that. There are now technologies that move beyond software slicing, which you see here in pink, right? Which are MPLS-TP, another a protection protocol, segment routing, a recent development, fairly recent development in layer 3 traffic handling, virtual private networks. We now have hard slicing as well. I mentioned fiber, generally impractical. Flexible Ethernet, right? So flexible Ethernet is a way to hard slice data. So this is, whereas in the past, maybe we used quality of service to bump the priority up on an important customer's traffic so they wouldn't ever encounter congestion through the network. But that doesn't help with latency, right? What hard slicing does, and flexible Ethernet in particular, is literally reserve a hardware path through the network. So it reserves processor, memory, and processing power all the way through the network for a particular customer. And this can be done on demand. As a customer comes in, needs us to clear the way, needs to build a hard path all the way through the network, then we can stand that up dynamically and drop it dynamically. So to kind of hit that point again, soft slicing is something that you're already familiar with in all likelihood. It is simply segregation of traffic, and that can help with congestion, right? Hard slicing is an advanced level of traffic segregation that literally reserves hardware for only that customer. So no other customers can use it. There is no comparison of priority bits. There's no evaluation whether you have higher priority or lower priority. There is simply, I'm building you your own lane and no one else gets to use it. And we can do that dynamically. So this is one way of making sure that traffic that your customer is paying, hopefully a premium for, going all the way through the network appropriately. This is one way to do that, right? One of many ways that we can do that today. 400 gig. So I mentioned one of our customers recently bought a 400 gig network. This has really become the de facto standard. And I'll tell you why, right? There's a couple of reasons. One is the 100 gig standard was a benefit. Certainly it was 10 times 10, but there was a 100 gig client interface as well as a 100 gig network interface, right? So we had some symmetry there. It worked very well for network deployment. A few years ago, 200 gig came out, but only on the network side. So we were able to carry two 100 gigs in a 200 gig wavelength on the network side, but no client interface, right? Today we have 400 gig client interfaces. They can carry four 100s, and of course there is a 400 gig network interface. So if you take a look at this graph, you see an industry analyst's projections into next year for 400 gig adoption. 100 gig is shown in the red. That is going to continue to grow. 100 gig is kind of a standard building block for client interfaces and for some network interfaces. 200 gig is going to start pinching out as we get into the future. And this is simply for a couple of reasons. One, there's no 200 gig client interface. And two, as people move to 400 gig, 200 gig interfaces are going to get more and more expensive, right? Economies of scale, people are going to buy less, they're going to make less, they're going to be more expensive. 400 gig is really going to take off, right? And we end at 2025 because I expect by the end of next year, we'll probably have an 800 gig standard. And we'll have to see what the network does then. Today, 400 gig is the top end of an Ethernet interface. Here's the big reason why 400 gig is where folks are moving today. And that is that, in briefly, a 400 gig optic is very close to the price of a 100 gig optic, and in most cases is cheaper than a 200 gig optic. Okay, so I'll say that one more time. 400 gig optics are approaching the price of a 100 gig optic, right? The most expensive I've seen a 400 gig optic go for is about 125% of a 100 gig optic. So even at that high point, you're paying 25% more and getting 4 times the bandwidth, right? So it really makes a lot of sense if you think you're going to use that eventually, right? Obviously, for folks that 400 gig is out of reach, maybe your service area is just not going to get there. Totally fine. 100 gig is going to be with us for a long, long time, right? But for those that 400 gig makes sense, it makes a lot of sense, right? Just from a purely economic standpoint. So here's another customer case study. This is kind of everything that we've been talking about wrapped up in one, right? So this is roughly 2,300 kilometers of fiber that we are lighting up with a DWDM solution. And there are layer 3 routers on top of this in every location. This is primarily a wireless backhaul network servicing over 1,000 towers in the West and Midwest. This network is sub 50 millisecond protected, right? At every location around the network, there is an express route back to their data centers. And so each one of these locations is protected and then dual homed to almost, I believe there are 3 data centers now, right? So lots of redundancy built into here. This originally started out as a 200 gig network. Everything was running 200. That was the top end speed at the time. But now it certainly is capable of running 400 gig. On the DWDM side, we can run 1.2 terabit, and we won't be removing any chassis here at all, right? This is a network that went in over 5 years ago and has no end date in sight in terms of its ability to handle the speeds and feeds that have come out this year, right? Okay, so I want to pause here for a minute and let everybody catch their breath and check in with my teammates and see if there's anything we need to address.
I think we're good for now, Jack.
Okay. All right, great. Thanks. All right, so let's move on to Muse. Muse is our management solution. And so what I want to express to you is the state of the management application today, right? Automation, I've used this word a couple of times in my presentation so far. Automation is not AI, not yet. AI certainly is moving forward, but I think we'll keep an eye on it in the news before we start putting it into management applications. But what automation is it is taking a lot of the repetitive tasks that are necessary to run a network and, well, simply put, reducing them from 12 clicks of the mouse or 20 clicks of the mouse to 1 or 2, right? And automating all of those additional steps so that it's done the same way every single time, allowing you to customize it, obviously, for the customer and so forth, but takes a lot of that grunt work out of what it takes to provision a service, to monitor a service, to troubleshoot a service. A lot of that can be done with templates, which we'll talk about, but there is also a workflow engine built into the management system. So once you have analyzed your workflows, right? So a simple one is I get an order from sales. I look at what who the customer is. all their details for connectivity, and then what it is they want, what type of service it is. Is it gold, silver, or bronze type service? And then I set about going through screen by screen and configuring that service, right? A workflow engine can allow you to build all of those tools in. So with a single click, you can select that particular type of process and have it go through and create everything that's necessary until it needs human interaction. And then you can enter IP addresses, host names, customer names, site location, all of that, right? So the workflow engine essentially automates that grunt work. Templates we'll talk about here in a moment. Remember when I talked about openness being unlocked, right? And working and playing well with others. This, the top right box is a good example of that, right? So there are NBIs, are northbound interfaces. This means our management system talks to other management systems. Maybe you have a manager of managers on top of this system. So we can send data northbound to another application. SBI is southbound interfaces. So a southbound interface from our software goes to individual devices, whether they're ribbon or other vendor devices, other monitoring devices, and so forth. So we have northbound and southbound communication using standardized interfaces, APIs, and then standard programming languages. Additional visibility via analytics, right? So we want to take the invisibility away from the network, right? What's happening? Where is it happening? And why is it happening, right? That's what our analytics are designed to provide, right? The information that they're designed to provide, with an eye to giving you better knowledge about how your network operates and where your network's going in terms of its trends, so that you can perform preventive maintenance, upgrades, whatever you need to do to keep things running before the red blinking lights come on, before the trouble calls come in, right? That's the purpose of the analytics modules. It is a cloud native architecture. It can be hosted in the cloud if you wish. Most of our customers elect to host it on their own virtual machines inside their operation. And we're open to either one of those. It uses a Kubernetes microservices architecture. Fancy words, if you're not familiar with those, that simply mean it's modular. So if you need the DWDM module, then you snap that in. If you need the routing module, you snap that in. If you want the OTDR module, you snap that in, right? Upgrades to any of these individual services are completely unimpactful to any of the others. It is the newest, most open architecture for software today. So Muse obviously provides complete FCAPS capabilities. I talked about business analytics. It is your single pane of glass into everything that Ribbon provides from an IP optical standpoint. Whether this is DWDM, whether it's switching, whether it's routing, any of our analytics modules, all of that is done from a single screen with no swivel chair requirements, right? To go look at a different screen and try and find out what's going on. It is customizable on a per user basis. So for instance, the graphical screen that you see there, each of these 6 windows, whether they're tabular or bar chart, pie charts, what have you, these are all what we call widgets, right? And these are customizable based upon customer, the type of data, the type of analysis you want to do. Really, it's your the big board, right, to see what's happening out on your network and with your most important customers. This might be how the network administrator or your CTO has a login to Muse, right? He just wants to see the top level red and green lights. Down at the bottom here is a screen that perhaps a network engineer or a NOC engineer might use. It's got a topology diagram. It shows you the shelf, the actual shelf view with the cards in it. Provisioning is done by opening that shelf, opening the card, double clicking on the card, clicking on a port, clicking on the termination port on the other end of the network, and then clicking the create button, and then it'll create everything across the network for you. So from an automation standpoint, from a friendliness standpoint, shallow learning curve, very graphical, very easy to operate. It's really the best in the industry today. For those of you that love command line interface, I have one of those too, right? It's a full-featured command line interface, good for scripting. I know a lot of you guys like to do that. The command line interface has all of the capabilities in terms of provisioning, troubleshooting that the graphical does. Graphical obviously gives you pictures along with the text, right? So however you like to work, we've got you covered. So this is part of that automation. I just wanted to kind of draw this out. This is a sample of templates that are available within Muse, the management system. These, as you can see on the slide, they are fairly descriptive in terms of what type of service they're for. There's a little graphic that indicates, whether it's a point-to-point or a mesh type solution. There's bronze, there's silver, there's gold, there's premium, protected, unprotected. So a number of default templates come with Muse. There is also an engine that lets you define your own template. So ideally, what you have when you get that order from sales and it says this customer needs a protected service, point to multi-point, and they need gold level latency, right? Then you'll have a template for that, right? You productize your network in sales. Why not productize it when you configure it instead of having to do every one from scratch? That way, you've got exactly what you need at the touch of a button. All you have to do from these templates is enter in the specifics for that customer, but the structure itself is already there. So automation, taking multiple clicks to just a few clicks, improving your time to revenue, time to market, and obviously eliminating an awful lot of opportunity for error in terms of, fat fingers. They happen, right, to the best of us. Here's the OTDR management. This is something that virtually every one of our customers purchases. I'll just be transparent. For what we charge for this, you pay for it about the second time you use it. Very straightforward. This is an OTDR environment that gets installed with your network on day one. So you have signal generators and filters that will shoot OTDR shots for you in line and in service anytime you want to from your desktop, right? No more handheld meters. You don't need to roll a truck. You don't need to find the patch panel. You don't need to disrupt traffic. It runs at a wavelength outside of the data transmission wavelengths. So it is completely unimpactful to your traffic. You can run it on your production fiber. And you will get a trace, just like you're seeing here, just like you're familiar with OTDR. Most importantly, not only can you kick it off manually, but it will detect breaks, loss of signal, and it will automatically shoot an OTDR shot and then send you a message within a minute or so of exactly where that loss of signal occurred, whether it's a break, is it a patch panel, did somebody yank out a fiber jumper accidentally? Let's say it's a fiber break, most common. It will measure where that fiber break is and tell you within a few meters, either way, where that break is. So you're still going to roll a truck, but it's going to be a splice truck, right? Instead of someone to go find the handheld meter, find the patch panel, shoot it, figure out where it is, drive out there, and then evaluate the situation, right? So the time that it takes to diagnose a problem and then get it repaired is dramatically reduced with this solution. Um, and like I said, it's very, very cost effective in terms of its initial cost. And then, after you've used it a couple of times, every time after that, it's just money in your pocket. All right, so kind of wrapping things up for Muse, we're looking at automation and capabilities that allow you to provide or that provide to you and allow you to gain greater visibility into your network, allowing you to reduce that operational cost effectiveness, right? Operational cost, not included in all the funding coming from the government, right? So it's important to make sure when you make a purchase that OpEx is a huge part of that, right? CapEx utilization, additional visibility just means your investment's going to be better used, right? You're going to be able to tell when congestion is starting to occur. You're going to be able to tell where parts of the network are perhaps not being used as much as you thought they would be, right? Maybe you can move resources around. Improving time to revenue, time is money. I really don't have to say anything more. You're all experts at that, right? And then finally, we like to work with other vendors, quite frankly. We have labs in all across the United States and, in fact, around the world where we do a lot of interoperability testing. You have a device that you want us to work with, send us that device. We can put it in the lab and we'll run the tests for you, right? That's something that in our view is a necessity. It's table stakes, if you will, to work in networking today, right? We have to be able to interop with our partner vendors. Okay, so I'm going to wrap this up with this final slide. Everything we do is standards based. We are a global company deployed in the majority of countries around the world, over 140. Literally hundreds of millions of end user customers are running on Ribbon gear today around the globe. Our technology, particularly in our management solution, is truly disruptive, right? In the most positive sense of that word. I hope I've given you a taste for that. We are more than happy to run a remote demo of Muse for you and let you see for yourself how groundbreaking and game-changing it is. All of our support for you, our North American customers, is based right here in the United States, right? It never rolls to other countries, never rolls to call centers. It is run right here in Fort Lauderdale, Florida, by trained technicians that have been there really a minimum of 15 years and are providing that tier 2, tier 3 level of support right off the bat. We are Buy America Act and BABA compliant. For those of you that don't know what that is, if you take money from the government, they're going to make you, in most cases, sign a piece of paper that says my solution was Buy America Act or Build America, Buy America Act compliant, right? If you go with Ribbon, we can handle that for you, right? Our solutions meet those requirements. And then finally, even during the darkest days of the logistics snarl in the past few years, we were delivering between 10 and 12 weeks on everything in the catalog, and we're still at that point. So if you order it from us, you're going to get it from us within a very reasonable amount of time. Okay, that's what I have for you today. Here's my contact information. I'm not a sales guy. I don't even play one on TV. More than happy to talk technology with you. If you just got questions about what we talked about today, feel free to shoot me an email, give me a call. Happy to talk with you. If we need to get a sales guy involved, happy to do that as well. But I'm more of an engineer, so let me know what questions you have. And with that, we are right at the top of the hour. So I've left almost no time for any questions at this point. But if we do have a couple, happy to take those.
Thanks, Jack. And I'm not sure, I'm not seeing your final slide there with your contact information. Just want to make sure that you have it on that slide.
I do.
Okay. Probably just something on my end. Also, below the slide, you should see a note there with Elizabeth Page's contact information as well. So please take a look at that. Don't forget the downloads we had for you, the Intelligent Middle Mile white paper, as well as the link to some more details around all of our rural intelligent network solutions. So yes, at the top of the hour, we did have a couple questions come in. We're going to handle those offline since we're right up at the top of the hour. But I did want to thank everyone for attending today. Thank you, Jack and Elizabeth and Isaac, for being on with us and answering all the questions. You'll be getting an email later this afternoon with a link to this replay so you can rewatch the whole thing again. And if you have any questions, please feel free to reach out to us at that point. Also, attach the slides from today's presentation as well. So again, look for that to your inbox late this afternoon. Again, thanks so much. Please continue to subscribe to Ribbon's channel on Bright Talk. A lot of good content posted there regularly. And we look forward to seeing you all on our next webinar coming shortly down the road. Thanks and have a great day.
Thanks.